Okay, our last free response before the test. So we're given a function f and a function g for all real numbers, and then we're asked to find the interval of convergence for f. So we're going to use this general term here. We're going to take the limit as n goes to infinity of a to the n plus 1 over a to the n. So this is I'm going to go ahead and go to the flip the guy step. This is n plus 1, x to the n plus 1, all over n plus 1 times the original flipped, n plus 1 minus 1 to the n, and x to the n. Okay, so now we're going to start simplifying some of these things. I'll move over a little bit so today you can see, unlike yesterday. Alright, so we're going to first deal with these negative ones. Okay, so that leaves me with negative 1. It appears I have n plus 1 and n plus 1 in the top. So I have n plus 1, n plus 1. So I've taken care of this and this. And in the bottom I have n times n plus 1. Ew, this is actually n plus 2. So n plus 2 times n. Okay, got that. Taking care of that. And now we've got this one, and it leaves me an x in the top. So I'm going to do a little bit of rearranging, pulling anything not involving the n out front. So that leaves me with the absolute value of minus x, the limit as n goes to infinity, n squared plus 2n plus 1 all over n squared plus 2n. And we know that if we L'Hopital this a couple times, this limit's going to be 1. So we're looking at solving this inequality, which I think we've done enough of these by now to know that this is going to go between minus 1 and 1. So now we need to check endpoints, because remember that you're being asked for the interval of convergence. So we need to check at negative 1 and 1. So we're going to test negative 1. So let's see what our series looks like. So this is negative 1 to the n, negative 1 to the n, all over n plus 1. So when I plug in a negative 1, my series, these negative 1s cancel each other out, so to speak, and then we're left with n over n plus 1. So if we start writing out a few of these terms, this is 1/2 plus 2/3 plus 3/4, and we can see that these are growing without bound, so this actually diverges. So negative 1 is not included as an endpoint. Now we're going to test x equals 1 in our original, so it gives me negative 1 to the n and 1 to the n all over n plus 1. So this is going to be minus 1 to the n over n plus 1. And if we start writing out terms, it's going to look something like minus 1/2 plus 2/3 minus 3/4, and so on. So my use of, this is a Leibniz, so 1, 2, 3, Leibniz, 1, 2, 3. All the use of n's are positive, so we pass this one. Is use of n plus 1 less than or equal to use of n? No, we fail this, so we actually diverge. So our interval of convergence is simply what we came up with from the ratio test, so we can write it either way. Let's go on to part B. So this sounds worse than it is. Just do what they're asking you to do and try not to think about it too much. It says the graph of y equals f of x minus g of x passes through the point 0, negative 1. So these are the coordinates x, y. So we're asked to find y prime of 0 and y double prime of 0. Determine if y has a min or max, or neither. So we're going to start off by finding y prime of x. So that's going to be f prime of x minus g prime of x. And we don't need to do a lot here. We just need to write out a few terms. So this is going to be, f prime is going to be something like this, minus a half plus 4/3 x minus 9x squared over 4 dot 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 minus g prime of x would be minus 1 over 2 for 2 factorial, and then plus 2x over 4 factorial, and then minus 3x squared over 6 factorial, and then some dot dot dot. So we're asked to find y prime of 0, which just means we're going to plug in a 0 for x. So you can see that any of these terms involving x are just going to drop out. So what are we left with? Minus half, and then minus a half, so 0. So our derivative, first derivative is 0. That means we have a max or a min. So to figure out which one it is, now we need to take a second derivative. So let's take the second derivative of x. So we're going to end up with 4/3 minus 18x over 4 dot dot dot, and then we're going to subtract from there. We have 2 over 4 factorial is 24. 24 minus 6x over 6 factorial dot dot dot. And we're evaluating y prime of 0 again, so anything involving 0 is going to drop out. So essentially what we're calculating is 4/3 minus 2 over 24, getting a common denominator. I get 8 times 4 is 32 over 20.